I'm truly excited and honored to be here and present you our project, extracting medical procedures from documents, which was done in collaboration with PassportCard. But before we begin, let's start by introducing the dear people involved. So Maya, my mentor, Ilana, data science manager in PassportCard, and Lital, data science in PassportCard, and also a graduate of this program. Here's something you should know before you go on your dream vacation. It's 2013. I go for a big trip in New Zealand. And one of the popular attractions there is go for a whale watch boat tour. As a tourist, I joined one. But unfortunately, the conditions of the sea at that day were very bad. So bad that I got seasick. So seasick that they had to turn the boat back to shore and call an ambulance. A few weeks later, I get a bill of almost 800 New Zealand dollars. And here's what you should know. Always arrange your travel insurance in advance. Fortunately, I did so, and the travel insurance company, PassportCard, covered all the expenses. And PassportCard is the biggest travel insurance and relocation medical insurance group in Israel. And they process many claims as the one I submitted. But they have a problem. They want to estimate the true cost of medical procedures. And this is where this project came into play. We wanted to enable PassportCard to perform reliable cost estimation of such procedures. And we plan to do so to get them closer to this goal by assigning procedure codes to each claim. But what does it actually mean? So we can actually decompose it into two sub-goals. The first one, the more basic one, is extracting explicit codes as the one we see here, and we will see more examples soon. And the second one, more advanced, is assigning codes to free text. But as with any project, and this was no exception, it has challenges. First challenge is that we didn't have any label data whatsoever. We just got a pile of documents, and we had to learn, study them, and of course, perform the labeling work by ourselves. Second of all, the data itself is very sensitive. We are talking about private medical documents. So we were limited to use only internal tools of PassportCard that comply with the privacy regulation. And third of all, I was a single student. So of course it affects the capacity and the redundancy. For the tech people in the audience, a quick overview over the technical stack. So all the coding was done in Python. I use VS Code. I use interchangeably ChatGPT, Grok, and Claude. The experience logging was done to Databricks. The LLM I used is GPT-4 Mini, and the OCR is Microsoft Azure. But what did we actually want to extract? So say hello to CPT codes, the most widely used coding system in the world. Basically, 5-digit numbers that can be roughly divided into 6 main sections, such as anesthesia, surgery, radiology. And CPT codes are extremely specific. You can see here an example. Psychotherapy treatment, depending on the amount of time this treatment took, it gets different code. So you can imagine why there are over 11,000 CPT labels. And for those who are familiar with the data science terminology, it gives this problem the name extreme multilabel classification problem. So now we are ready to dive into our first goal, the extracting of explicit CPT codes. So let's get familiar with some examples. Can you spot the explicit codes? Let me help you. So take a look, and let's talk about them more deeply. First of all, in terms of the sources of such documents, they can come in the form of a PDF or an image. They can be either digital, scanned, or photographed. And of course, they can be printed or handwritten. And it affects the clarity of the document, and we had to deal with it. Second of all, PassportCard is a global medical insurance, and therefore the documents can come in different languages, though we try to narrow it down to English. And as we saw, there is no uniform format that we can rely on for extracting the codes. And there are other challenges as well. For example, there are many false positive candidates, meaning non-CPT 5-digit numbers. For example, PO box, zip code, amount of money, and invoice number, you name it. And we had to deal with that as well. Here is our solution pipeline. On your left side, you can see it gets as an input raw file. And on your right side, you can see it outputs the predicted CPT codes. Basically, we can divide it into two main steps after the image to text is performed by the OCR. The first step is the extraction that is done independently by a regular expression and an LLM. At this step, we extract potential CPT candidates. Later on, at the classification step, we classify whether each candidate is a true CPT code or not. Ready to see the results? Let's see them. Here are our results. So in red, you can see the baseline, the current solution by PassportCard that is in production, not really used. On the pink and blue, you can see our solution. The solution pipeline can be tuned to be either precision-oriented or recall-oriented. And the results talk for themselves. We were able to achieve over 150% of improvement over the baseline. But wait, there is more. We were able to deliver also a few bonuses. One of them is a framework for marking predictions on documents. So here we are talking about predicting at the extraction level. And we basically circle the potential candidates and use the stoplight color scheme to mark whether each extraction is a true or not a CPT code. So in red it's not, yellow maybe, green is of course. And why is it important? Because it allows to facilitate human in the loop. So now we can talk about the more advanced goal. But why do we even need it? Well, basically, not all documents contain CPT codes. In some, they are just obscured, as you can see on the left side. And in others, there is a bunch of text that we have to classify. So the solution we developed is somewhat similar, although here we only used an LLM, and we also have an optional step for predicting more coarse level, higher level, instead of explicit CPT codes. And this is why it is because the CPT codes themselves are extremely specific, and sometimes the text provided in the document is not, does not have enough information. So let's see our results. So what we did here, you can see the baseline in the pink and the blue. Basically, we took documents that contain both explicit codes and corresponding text. And we first ran the pipeline of explicit codes. And these are the results in blue and pink. Then we removed the CPT codes from these documents and ran the current pipeline. And you can see the results in yellow. And in orange, instead of predicting explicit CPT codes, we predicted the clusters. And overall, if we set the performance of the explicit CPT pipeline as 100%, we were able to achieve more than 56% of this baseline. And it is not trivial because recall that CPT codes are extremely specific. So let's wrap these things up. We were able to address both goals, the basic one and the advanced one. In terms of the basic goal, we implemented an end-to-end pipeline for extracting explicit codes that is production ready and is tunable. We also delivered extraction level prediction marking framework and of course We started with no label data, so we provided also 106 label files. In terms of the advanced goal, we implemented a proof of concept for classifying free text to CPT codes. Questions will be later, now or next to the poster, but thank you very much for your attention.